Look at this bridge. It spans nothing, just dry, cracked earth. An abandoned monument to a river that simply isn't there anymore. This isn't a dried up creek from a drought. This is the Arctic. And this river didn't just shrink, it vanished overnight. A few hundred miles away, another body of water, a large lake, did the same. This isn't science fiction. It's the terrifying, accelerating reality of a thawing world. To understand how a river can disappear, you have to understand its foundation, permafrost. It's not just frozen dirt. It's rock, soil, and critically, massive, ancient blocks of ice, sometimes frozen solid for tens of thousands of years. It covers about 24% of the Northern Hemisphere. For the Arctic's landscape, it is the glue, the concrete, the impermeable barrier that dictates where water flows and where it pools. The top layer, the active layer, thaws and refreezes seasonally, but the ground below remains eternally locked. Until now. The global temperature rise, exponentially faster in the Arctic, is attacking this frozen glue. As the permafrost warms, the ice within it, often in the form of massive subterranean wedges, begins to melt. This melting forms small, subterranean channels. Now picture a large lake, held in place by a massive, frozen bathtub. That lake sits directly on permafrost. When a crack finally forms in that ice-rich foundation, the water does what gravity demands. This is known as catastrophic lake drainage, or tap on the bathtub. We have documented cases that defy belief. North of Inuvik in Canada's Northwest Territories, one lake, a significant body of water, drained completely in just 16 hours. Think about that. An entire freshwater ecosystem, a source of life for local indigenous communities, gone in less than a day. The lake water, relatively warm compared to the permafrost, melted its way down a newly opened channel and poured into the surrounding, softer tundra, or an adjacent river system. This process not only drains lakes, it is one of the primary drivers of river diversion. When a river flows, permafrost acts as a stable, hard bank, forcing the water to stay in its established channel. But when that bank thaws, it transforms into a muddy, unstable, slump-prone hillside, a process called Thermokarst. As the ground collapses, the river can spontaneously find a new, lower path through this soft, newly thawed landscape, abandoning its original course entirely. This is how a bridge is suddenly left stranded over a dry ravine. The river has literally carved a new path of least resistance through the melting Arctic landscape, sometimes shifting kilometers in a matter of months. The disappearance of a river or a lake isn't just a localized problem. It triggers a cascade of global and regional crises. First, climate feedback. When permafrost melts, the ancient organic matter, frozen plant and animal remains, begin to decompose. This releases massive amounts of carbon dioxide, and, more alarmingly, methane, a greenhouse gas vastly more potent than CO2. The thaw accelerates the warming, which accelerates the thaw. It's a terrifying positive feedback loop. Thawing permafrost also releases ancient, frozen contaminants. Scientists are now observing rivers turning a rusty, orange-brown color in Alaska. This is the result of iron, heavy metals like mercury, and acid being flushed out of the newly thawed ground into the water supply. It poisons the ecosystem and threatens the clean water essential for indigenous communities. From pipelines to roads, airport runways, and the very homes of northern communities, the ground is literally disintegrating beneath them. The Arctic is often framed as a distant, abstract concept, but the phenomenon of the vanished river is a stark, measurable, and unmissable sign of global climate change. What we are witnessing is not a gradual transformation, but a rapid, non-linear collapse of the landscape, driven by the loss of its frozen foundation. The forces that shaped these great northern rivers over millennia are being undone in a single human lifetime. What's happening beneath the Arctic surface isn't just melting, it's movement. When permafrost thaws, entire landscapes begin to slump, tilt, and breathe. Satellite imagery now shows regions of northern Canada, Alaska, and Siberia literally sinking, centimeters every year, as the once solid ice beneath the tundra transforms into mud. This process, called subsidence, is warping entire watersheds. Rivers don't simply vanish, they fracture into smaller, chaotic braids, breaking apart deltas that had been stable for thousands of years. One of the most alarming examples comes from the Lena Delta in Siberia, one of the largest in the world. Scientists comparing satellite data from 1984 to 2023 found that over 10% of its small lakes had drained or merged into new channels. The patterns weren't random. They followed the invisible skeleton of thawing ice wedges buried beneath the surface, carving new veins into the Arctic landscape. And there's another twist, one that connects directly to the global ocean. As rivers in the north collapse or reroute, they alter the freshwater flow into the Arctic Ocean itself. This changes salinity and density, two of the critical drivers of the global ocean circulation, the conveyor belt that moves warm and cold water around the planet. A disruption here doesn't stay local. It reverberates through weather patterns thousands of kilometers away, from monsoon cycles in Asia to rainfall in Europe. The Arctic, once a passive receiver of climate change, has become an active amplifier. For the people who live there, this isn't theory. Entire villages are relocating because their ground is literally collapsing. In Nunavut and Yakutia, wooden houses tilt at impossible angles. Airstrips buckle. Pipelines crack open. A runway once perfectly level now has a vertical drop of half a meter at one end. In Alaska's Bethel region, thawing permafrost has forced emergency relocations as the Kuskokwim River changes its course. For communities that rely on predictable ice roads and frozen rivers for food, medicine, and connection, the loss of stability isn't just environmental, it's existential. And as if that weren't enough, ancient biology is stirring. Permafrost is nature's freezer, a vault of prehistoric life. In the last decade, scientists have revived moss, nematodes, and even viruses from samples tens of thousands of years old. While most are harmless, the existence of viable pathogens frozen since the Ice Age adds another layer of unease. The Arctic thaw is not just rewriting geography, it's unlocking time itself. The rivers that vanish are only the surface symptom of a much deeper transformation, one that ties physics, chemistry, biology, and human survival into a single, melting equation. The planet's largest freshwater reserve and its immense carbon store are held together by a fragile, frozen balance. When a river vanishes, it's not a local anomaly. It's a global distress signal. The Arctic is telling us that the clock on permafrost is ticking, and we need to listen. If you believe the greatest mysteries are the ones science can actually explain, subscribe to the channel. Veil Origins. Impossible Truths.